Guess what? You may not be able to see them. Somebody is innovating that is going to eat your lunch.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Dave Finch. Today we're talking all about innovation and what that means to the people who actually have to do it. If you're playing corporate buzzword bingo, you want to be in possession of the card that has innovation written on it, because most executives love to tout innovation as a tentpole of their corporate culture. But true innovation has to be an intentional and highly operationalized effort, capable of weathering downturns, lean quarters, and attrition. It requires funding, time, resources, and this is where most companies fall short. So how does someone in the trenches of circuit design take part in innovation, especially if their company doesn't know how to support it? How can an individual engineer bring new ideas to life when they're always weighing risk and reward? After all, the risks of innovation are very real, and so are the rewards. Where does risk make sense for an engineer whose primary responsibility is to deliver functional designs on time and under budget? Today we'll hear from two engineers and a CEO, each with a unique perspective on the why and how of creating something new. Jianwen Shao, Power Applications Manager at Wolfspeed, a Cree company, couches the innovation discussion in the example of silicon carbide MOSFETs.
Engineers need to look into this new technology.
And Laura Callahan, an engineering team of one at Decor Lighting, shares her approach to exploring new technologies while mitigating risk.
You need to define, what does innovation mean to you?
But first, we're joined by the current CEO of Cable Labs, the former CTO and head of innovation at Hewlett-Packard, author of Beyond the Obvious, the groundbreaking book on innovation, and host of the nationally syndicated radio show and podcast Killer Innovations, Phil McKinney. As an engineer himself, Phil's pragmatic and no BS approach to innovation transforms companies that provide lip service into ingenuity powerhouses.
Well, the biggest thrill I get from innovation, just when I engage with somebody, is I remember the very first time when I went from just something like a raw idea, and I finished up my first product, and it was on the shelf, and I could walk into a store and I could point to it, and go, I did that, and I kicked butt, right?
Yeah.
When I was CTO at HP, I always told people the best thing I could ever do when I was CTO at HP was to ship an engineer's product. Right? Because when that thing shipped, they could take their family into a Best Buy store, point to that product and say, I did that. I achieved it. Mm-hmm. And once you got to get bit by that bug once, man, you just keep chasing. You keep chasing to get that feeling again and again and again every time. And that's the kind of stuff I love.
Yeah.
But it's key is knowing what really drives your passion, right? Versus, doing something that's not your passion and you're just doing it. If you're just doing it and it's not your passion, guess what? You're probably not going to do a very good job at it.
Right.
And it's going to show.
Is the scope of innovation necessarily limited to the product or services you're providing, or does it have to be treated as sort of an organizational or operational imperative across the entire organization?
You constantly have to be innovating everything inside your organization. It's not just about, can I go invent a new widget, and that widget, is the answer to my innovation effort. You need to innovate yourself, and you need to do that on a continuing basis, because guess what? You may not be able to see them. They may not be right in your line of sight, but somebody is innovating that is going to eat your lunch.
I feel like there are a lot of executives who love the buzzword innovation, right? Clayton Christensen, disruptive innovation, the best kind of all. And yet, with the exception of, ST Microelectronics, which is so engineer-centric, many of the tech executives that I've worked for over the years, they couldn't tell you who their customer even is.
Well, the funny part is with any innovation, right, is you may think you know your customer. You don't know your customer. You are not a proxy for your customer. No matter how close you think you are always a poor proxy to think what your customer will like, want, need, willing to pay for. And that's hard for engineers, right? Because we think well, if I design for myself, then every other engineer would like this.
I have been used in different roles for companies as the quote unquote voice of the engineer. And it's very difficult because I keep having to tell marketing teams that I'm one engineer. I can't speak for all engineers. How can companies and even individuals really understand who their customer is? Because we all have biases and assumptions.
Well, exactly right. For me, my belief around how do you get into the heads or walk in the shoes of your customer is through observation, through ethnographic studies, watching them in their natural habitats. And for me, when at HP, such a large portion of our products were purchased in retail, the best place to observe is to observe them in retail.
Right.
I'm more interested in being there at the time of the purchase decision and then pulling out the threads as to how they made the decision to buy that product versus this other product. So, for instance, back at HP, most Saturdays you would find me standing in the retail stores for consumer electronics, whether that be Fry's Electronics, Best Buy,
right.
And I would just stand there and watch. And when a customer would look at products, including a product from HP, but they would choose a competitor's product, I would walk up, I'd introduce myself, and I'd hand them my business card. Now, quite honestly, it tended to freak them out because they would have this assumption like, oh my gosh, HP's revenue is so low that executives are stalking customers in retail to buy a product, right? I'm like, no. I'm just interested as to why you looked at this product.
Yeah.
But you chose that product. Why? What was your thought process behind that? My favorite story is Best Buy in Fullerton, California. I was down visiting my son. He was doing his undergraduate work at Cal State Fullerton. I'm sleeping on the couch in his apartment, which I always think is a funny concept given I was paying the rent. And I'm the guy on the couch. He gave me the couch. He took the bed. I got the couch. So we get up Saturday morning, and I go, hey, I want to run by Best Buy. And, Logan, my son, goes, Dad, I'm not doing the stalker thing with you. We're not doing it. Because I used to make my kids and my wife go with me, so I wouldn't look like a stalker dude, right? And so I said, no, just 10 minutes. Because every Best Buy store in Silicon Valley, all the managers knew me. So I couldn't be like this hidden observer.
Right.
So I walk into the Cal State Fullerton Best Buy, and I'm standing there watching, and the store manager walks up to me and goes, can I help you? You've been standing here for like 45 minutes staring at my employees. So I introduced myself, hand them my business card, telling them what I'm doing. And one sales guy goes, well, all the products are doing good except for this one product. Nobody over 50 will buy it. I'm like, show me this product. So he walks me over to this HP laptop. And I looked at this thing, and it immediately hit me what the issue was. So, the keyboard deck is all silver. Well, the design team decided to say, well, if silver on the deck is good, then silver on the keys would be better.
Oh, boy. Yep.
There isn't enough contrast. You couldn't see the keys. As you get older, your eyesight goes, and it's hard to read. Yep. I called Houston, which is where the laptop division is at, and I said, you got to fix this. They fixed it. All I did was change the keys. We reintroduced the product, and the revenue came right back.
No kidding.
So it goes back to this point of where engineers think they know what the issue is, but unless you get out there and go face-to-face and engage with your customers, you are not going to be able to innovate a solution. Well, I shouldn't say you won't. You can always innovate a solution, but you can innovate a solution that has much higher impact, much higher value for your customers if you engage with them.
That's right. Engineers and social skills are not always in the same place at the same time. They also don't always assume that they are going to face tremendous resistance from their own coworkers and management.
Right.
Now, you refer to these people in your book as the corporate antibodies, and I love this. Because that's exactly the response. You bring in a new idea, and these people come out from all corners of the office and just attack until the idea is dead and flushed out. And I can promise you that Everyone who listens to this podcast has dealt with the corporate antibody response personally, probably many times.
Yeah.
You know, the last corporate job I had, I'd been brought in to manage a team of about 25 people, and every one of them was a top performer. But it was immediately clear to me that there was no formal operational process around what they were producing. So basically building houses without a blueprint, right? And everything that implies: low revenue, low margin, low morale, unhappy customers.
Right.
So I said, I'm going to structure this thing a little differently. We're going to develop and document formal executional models. This is going to streamline development, save us a lot of time, money, and effort. And, pretty quickly we achieved lower lead times, higher profits, happier customers. And I thought, man, this is an innovation. Corporate's really going to love this. But what surprised me was the amount of pushback from the executive leadership team. For some reason, they were extremely averse to change, right?
Yeah.
Like to the extent that they felt they had to defeat it. And now looking back, it very much resembled this antibody response that you describe. It even got to the point where they said, look, you're going to do this our way. And I said, thanks, but my way is clearly better. And they fired me.
Exactly.
So now, if you were there to coach me at that time, what would have been your advice?
Well, the issue with antibodies is that there are different kinds of antibodies.
Okay.
And each of them you had to deal with them differently. What you ran into was what we call the ego antibody. Mm-hmm. Some person at a senior level role who thinks it's their job to come up with the ideas. It's their job to come up with whatever the magic answer is, whether it comes from a CTO, a CMO, a CIO, it doesn't matter. Within their scope of responsibility, they see themselves as being the idea people. Mm-hmm. And if somebody else comes up with a really good idea that they didn't come up with, you just significantly stepped on their toes.
Okay.
And you will get the antibody reaction. So what do you do? And be quite honest, the ego antibody is probably the most common one you run into. So how do you deal with an ego antibody? How do you get around them? If you're an engineer and you got this really great idea, and here's the trick that I used at HP. I would come up with maybe some rough ideas, put it into a little PowerPoint, text only, no pretty graphics, go print it out on the printer. I would take that paper, crumple it all up. Then I would flatten it out on a table, put coffee stains all over that paper. Then I would go into the executive and say, something, I got this really crazy idea. It's just a rough idea.
Oh my gosh.
Can you give me some feedback on this idea, right? Well, obviously, if it's wrinkled, it's got creases in it, you got scribble marks on it, it's got coffee stains all over. It's not a finished idea, obviously, because you would never present a finished idea like that.
Right.
So you go in and you present it to them, and they go, well, that's kind of interesting, but you thought about doing this, maybe you tweak that a little bit. Here's the rule. Whatever they say, put in the slide. No matter how stupid it is, put it in the slide.
Yeah.
Now it's their idea. You've now subverted them to be a sponsor for your idea rather than being the antagonist who's throwing the bombs at you. And what you have to do is understand kind of who in your organization you've got to play this game with.
Right.
You want to subvert them into your project rather than waiting for the reaction and then trying to deal with the reaction, because that's very hard to do after the fact.
Yep. Well, the second mistake clearly that I made was I only redoubled my efforts.
All chips on the table.
Well, because these things made sense, right? They'll see the revenue, they'll see the margin, they'll see the repeat business. And eventually they'll stop beating me up.
No. The thing you have to be careful about with antibodies is logic does not apply. You were applying a logic approach, which is, this is great return. People really like it. Look, I'm doing these at a very low cost. We can put these out on a very quick basis. Isn't that all good? That's logical. It makes logical sense. Does not apply with antibody responses.
Oh, boy.
It's about getting it does you no good to just do everything you can. It's your idea and you don't know what you're talking about, and I'm going to push this thing through, and nothing ever happens. The project never makes it to fruition. What have you achieved? The achievement comes from seeing your idea become real.
Yeah.
And the way to do that is you can't go it alone. You have got to bring people into your project. You have got to convince people to commit time, resources, and eventually money to support your idea as much as possible.
Generally, companies hire smart people with good ideas. So why don't we see more killer innovations out there, more successes?
There's lots of ideas. Ideas are not where your issue is, right? So quantity of ideas is typically never a challenge. The availability of really good ideas. So the difference between just an idea and a really good idea, that's the gap. It's what we call the innovation gap. And there's two. The innovation gap, lack of supply of really good ideas, and then innovation delay. Once you've got the idea, how fast can you introduce that idea into the marketplace? That's it. That's the two missions of an organization. Solve your innovation gap and solve your innovation delay.
But if an organization doesn't operationalize this forward-looking mentality with a framework such as the FIRE method or whatever they choose to adopt, it will always be almost like you said, a hobby or a pet project, something that takes a back seat when everybody has to hit their call for the second quarter. Let's not talk innovation right now. Let's talk what are we going to do to close our revenue gap. So companies have to operationalize this.
Well, you have to have, there's a thing called the 7 laws of innovation.
Okay.
Which is actually the new book. Hopefully we'll get done here soon at some point. Law number 1 is the law of leadership. You can have all the other pieces, what we call the law of patience, right? Innovation takes longer than it thinks. The law of resources, you need consistent funding of resources, dollars and people and time. If you don't make those available, you're just fooling yourself. But ultimately, it requires leadership. Are the top leaders in an organization, are they just flapping their gums? Or are they serious about innovation? And it shows in their actions. How much time is your CEO spending thinking about innovation? Is innovation worth 5% of their time, 10% of their time? How much time are they really thinking about innovation?
In your opinion, are enough companies investing the right way in structured, formalized innovation?
Quite honestly, no, I don't think so. And I think large public companies have it much harder to commit to a resourcing model because this takes time. And it's always a risk. Look, if you're thinking that you're going to play in the innovation game and everything is going to come up roses, it ain't happening, let me tell you. If you want to be successful in the innovation game, be ready to be very frustrated. Because look, if you're doing innovation at world-class levels, 9 out of 10 of your projects are going to fail.
Okay.
If you claim to be doing innovation and 75% of your projects are successful, you're blowing smoke at yourself. You're not innovating.
Okay.
You're just playing the game of increments.
Yeah.
Right? If you do 1 out of 20, you're just throwing spaghetti against the wall. You have no process. 1 out of 10. That's world class. Some people just do not have the mental fortitude to sit there and watch at a 90% failure rate. How many CEOs do you know can sit there and look at 90% failure rate and go, woohoo, great?
Exactly.
None.
Exactly.
None. Right? And this is the advice I give all the time when I'm coaching and mentoring CEOs. Like, if you know you cannot handle watching a 90% failure rate, hire somebody to run your innovation effort and then stay the heck away. Measure them on the output, those projects that graduate out, not what happens inside, right? It's like, you're going to be frustrated.
Yeah.
But when you get a big win, it can carry you for a long time.
Moore's Lobby is sponsored by Eaton's Electronics Division. Every day, Eaton develops and delivers innovative new technologies and solutions that touch people at home, work, and play. Eaton provides products and services for medical, industrial, energy, consumer, and transportation applications. Learn more about Eaton's extensive portfolio of circuit protection, magnetics, and supercapacitor solutions at www.eaton.com/electronics.
So, if innovation means risk, assuming a 90% failure rate in some cases, where does it make sense for electrical engineers to stick their neck out? Well, sometimes our industry serves up a new opportunity, and the innovation occurs when engineers take a risk and reach for it first. As Power Applications Manager at Wolfspeed, a Cree company, Jianwen Shao is an important figure at the forefront of silicon carbide adoption. He's seeing more and more engineers embrace this newer technology despite the inherent risks of being among the first early adopters. Here's why.
the conventional technology is all silicon-based. It has been there for many decades. And these silicon devices are very good at lower voltage. For power semiconductor, typically they are working pretty well under 600 volt.
Mm-hmm.
So that's like MOSFET, super junction, empty mesh. Those type of devices are very good. Wide band gap have a different characteristics than the silicon. So wide band gap requires a higher energy to activate the atom so that can become a conductor. So that characteristic make like silicon carbide very good at high voltage application. For example, it can have very high electric field, which means that for the same thickness of wafer, the device can handle or sustain much higher voltage. It is very good for high voltage application, especially for 600 volt above. You can sustain much higher voltage, and because the thickness of the device is much thinner, so the RDS on is much lower. So basically, if you look at the high voltage devices, the RDS on, it is proportional to the thickness of your devices. The higher the voltage, the higher the RDS on. So now, because this property of wide band gap, for higher voltage, you can reach very low RDS on. I'll give you an example. We have 1200 volt devices. The lowest RDS on can be 13 milliohm 1200 volt devices.
Wow.
13 milliohm. So that's why conduction losses can be very low. And also similar benefit because of the material, the switching loss is much lower as well. So both switching loss and the conduction loss can be significantly reduced if you use the silicon carbide devices. That's why in electrical vehicle, they are very, very interested in silicon carbide technology now. So I think now if you look at the market, 9 out of 10 manufacturers, they are working on silicon carbide.
How are these being used in electric vehicles? Are they being used for power distribution? Are they being used for load management?
Yeah, that's a very good question. Actually, you can see in electric vehicle, there are a few blocks you can use that. The first is the drivetrain to drive the motor. So that's about, you can have that from 50 kilowatt all the way to 300 kilowatt.
Wow.
Very high power. That's a big chunk of application. Another one is the onboard charger, because you want to have that charger to be high efficiency and a very light load, small size. So this would love to use a silicon carbide MOSFET. Another application in EV is DC-DC. So you usually have a lot of electronics in the car. So usually use 12 volt. So you need to convert high voltage from the high voltage battery at 400 volt, 800 volt down to 12 volt. So that also require high efficiency, high power density DC-DC converter. You can use a silicon carbide MOSFET.
Are automotive companies still researching the viability of silicon carbide, or have they already adopted this technology and are currently using it?
It's in mass production already. For OBC, it's in production. And then EV drivetrain, it's close to being in production. Delphi, they already announced that they have developed that silicon carbide-based inverter.
Are these more expensive than just a traditional silicon device?
If you look at just the BOM cost, silicon carbide is more expensive than silicon. But however, if you look at the system cost, the system cost can be reduced because you have a higher efficiency inverter, then you use less power. So in other way, if you use a silicon carbide, you can use less battery, or you can drive your car in a longer distance for one charge. So if you consider all the cost, the silicon carbide give you a better ownership cost. If you consider the motor system, you potentially further bring cost down because you can increase switching frequency when you use silicon carbide devices. So when you increase the switching frequency, there's a potential there. You can reduce the size of a motor. However, you need to pay close attention to the magnetic loss in motor. So that's why a lot of research is ongoing now, how to design a motor in higher frequency. Definitely this will further bring the advantage of wide band gap in motor drive area. You know, you are audio engineer. Yeah. You know, the switching frequency, probably you are very sensitive to noise. So how high, what is the highest switching frequency you can listen, or the audio frequency?
Well, for humans in general, the rule of thumb is up to 20 kilohertz. My kids just played for me yesterday a 16 kilohertz tone from their phone to see if I could hear it, and I could hear it. It was it hurt my ears. 16 kilohertz.
So if you look at the market, if you use IGBT, typical switching frequency is 8 to 10 kilohertz.
Oh, really?
So that's really in your audible.
Yes.
Yeah. Yeah. So now when you drive silicon carbide, you can drive in the frequency that out of your audible frequency. I think that's a benefit.
In your experience, how are the design engineers responding to these new products that are more expensive and that they haven't used? Are they reluctant to design them into their systems?
Just about 2 years ago, Creed had a survey that for those major EV company, how many people are willing or plan to make the transition to use silicon carbide. Even 2 or 3 years ago, only one company was working on that.
Really?
Which was Tesla.
Okay.
And then just within 1 year, last year, when we do the same survey again, the majority would say they are going to transition to silicon, or they are doing the transition right now. I think right now it is in this tipping point that they clearly see that benefit. But of course, people see that maturity, and it takes some early adopter. They see that the success, and then people would follow that trend.
What do you observe from your customers when they're trying to make a decision? What are some of the factors that they look at when they're trying to decide which technology and then which component to use?
Basically, cost, performance, those two items always are linked together. So in some cases, performance can be higher priority. And to the end, cost is always important. So they need to see that system benefit, then they are willing to make that transition.
That's right. That's right. Anytime you can demonstrate a broader system benefit that's greater than the sum of the bill of materials, you start to see a natural progression of adoption. You know, like a new solution begins maybe as an engineering curiosity, and over time it becomes a viable and maybe even compelling option. And finally, we reach a tipping point where it no longer makes sense not to use it. One example that you and I saw together in the trenches back in the day was the race to replace magnetic fluorescent lighting ballasts with electronic controlled solutions.
That's a good example. Initially, cost for electronic ballast was higher than the magnetic ballast, but the performance and also reliability-wise, electronic ballast by far better than the magnetic ballast. And once the production in volume starts, the cost of the electronic ballast reduced dramatically. So that the adoption is widespread. Similar thing, it will happen in silicon carbide.
Are we starting to see that tipping point now where silicon carbide is becoming a must-have?
Yes, I can see that the trend. Yeah, so EV is high volume. So once this adoption starts, it will significantly increase the production for silicon carbide, and then in turn it will drive down cost, and then you will continue to expand the application of silicon carbide to other applications.
Yeah.
For example, power supply. You can see that just because this COVID-19, the server power supply demand will be much higher. right? Because everyone is doing Zoom meeting or online shopping.
Yeah.
The server demand is really high. If you look at the consumption, the electrical consumption for data center worldwide, that's about like 2% of the total electricity.
Really?
Yeah, just the data center. If you can increase efficiency of the power supply, you can have tremendous reduction in the power producing. So that the saving, not just the cost, but overall for the environment impact also can be huge. The volume for that power supply is very high.
If you're a design engineer working for any company out there, who in the engineering community right now should be looking ahead to the next 2 to 3 years and really seriously considering silicon carbide as an option besides EV and solar?
So what I can see that for the general just power, for the power supplies for server and the medical. So this is also very special application for medical power supplies for like MRI. Silicon carbide devices are very good for those high power power supplies. For other industrial like welding, industrial heating, high frequency, high power.
Sure.
So those, I think engineers who are working in this area, they need to pay attention and then start to use or learn about silicon carbide.
What would be your advice to an engineer who should be looking at this technology, but they're not sure, where to start or whether it's too risky or too far away to look at right now, too expensive? What would be your advice to engineers to start considering and start evaluating the technology in a productive way?
We see that all the time. Engineers want to use silicon carbide devices, but they don't know how. So that's why we create a lot of reference designs. We have a lot of white paper tips, also eval board to help customers learn to use the silicon carbide devices. So I think they can start with some companies like Cree, look for reference designs, look for eval board. They can start to play with these devices.
And I think that's one way that engineers can reduce their own perceived risk.
Yeah, I think that all of us, we have the tendency to use the technology we are familiar with. We don't want to take a risk. But it's to the point right now that the silicon carbide is in volume production right now, and it is in the real application. So engineers need to look into this new technology, need to learn how to use this device in their particular applications.
This segment of our show is sponsored by Eaton's Electronics Division. Need energy storage solutions for your design? Eaton has a broad supercapacitor product offering, ranging from coin cells to modules. Eaton's online resources and experts can support all of your design needs from ideation to production. Learn more about Eaton's ultra-high capacitance devices by visiting www.eaton.com/supercapacitors.
Often in our industry, the word innovation carries a connotation of seismic disruptions and quantum leaps forward. But even innovation in small measures becomes crucial when an engineer has a large enough role. As the entire electrical engineering department at Decor Lighting, Laura Callahan's design choices can make or break the success of their products. It's a tremendous responsibility, one that she loves, especially because her company prioritizes innovation.
Being really the only one, the buck kind of stops with me on a lot of the designs, opened my eyes to a lot of the mistakes I didn't yet know I could make, and made me a lot more comfortable relying on other resources.
So part of the innovation loop has to be the feedback. You would need to get feedback from the potential customers, and those might be retailers, landscapers, end users, but you are also part of the feedback loop, certainly for companies like Cree.
I think it's definitely a two-way street. We definitely love hearing from Cree and seeing what they have plowed ahead and developed for us. Usually it's a smaller package or higher efficacy or some new kind of phosphor that's giving a warmer color temperature, better CRI, something like that. And those kind of things open up a whole new world. And they saw the need because people like us were saying, hey, look, we're not building troffers, we're not building super spotlights. we need something in this package with these specs. And sure enough, these show up in the market.
Tell me about the innovation culture at Decor.
Sure. And when I heard we were talking about innovation, it's one of my favorite subjects. I think it's so fun because it is a really big buzzword in our industry, but it means something different to everybody. And I think that is absolutely the first step, whether you're a design engineer, whether you're running a company, no matter where you are in this chain, you need to define, what does innovation mean to you? Does it mean frequent updates, incremental changes? Does it mean every 5 years we completely disrupt with something brand new? And for Decor, it means typically we're doing incremental changes. Our increments are pretty big. Usually I'm looking at a 50% to 70% light increase, but that's usually the culture we're working in. So for us, because we're a pretty small company, we're able to invest in tools that mean the prototypes are going to mean something. And that, I think, needs to be at the core of every R&D department. There are so many tools now that hobbyists have kind of taken over that you can really show people something amazing without having spent a lot. So even when it comes to quick turn PCBs, right, there are some really great places, Osh Park being one of them. You can get boards pretty quickly, very reasonable cost. So it's playing a game, because so many of our things are, the end product is going to be cast metal, it's going to have a tiny footprint, all these things. All my prototype boards, I use an 0805 half-watt resistor, because then I know no matter what I'm doing, even if I missed horribly, I probably have that same package somewhere else, and I can always size down the power later.
Sure. Well, with innovation comes risk. And it sounds like one way that you are mitigating this risk is by minimizing your, we'll say, exposure during the ideation and prototyping stages. For example, utilizing low-cost or even community-backed development tools.
Absolutely. Because mitigating that cost and risk of development makes everything so much easier for the entire company. If you're going to make a mistake, it should be a less expensive mistake, ideally, right? You don't want to have gotten to your $8,000 tooling when you realize, oh, what do you mean I didn't leave a hole for power? And that kind of a mistake will scare your purchasing department forever, right? As soon as you say, hey, well, how about we do a new product release this winter? They'll say, oh, goodness, what are you going to do? How much are you going to cost me? So keep that ROI in mind all the time. And yeah, keep costs down. Risk kind of follows, because if it's a low cost endeavor, there are things I've thrown out to the market that I really didn't have a lot of research on. We just released a bunch of colored lights like red, green, blue, and people had requested them, but I didn't have a lot of solid data saying we need to do this right now to keep the company moving in the right direction. It just seemed like a good idea, and the cost was so low that the risk felt low as well. You really don't have to disrupt to innovate. You might just be filling kind of a niche, and if it's a low-cost development process, you're going to get a lot more through.
Absolutely. Innovation without execution is really a pointless exercise.
It is, but at the same time, you also have to be willing to part with your ideas for a time, right? That's something that I know I always still struggle with, is if I get emotionally attached to something that I think is crazy innovative and it's going to just rock the world, and it isn't quite the right time for the company to make that, it's never lost work, right? Record everything, put it in a file, and then when it is time, you'll be able to pull it back out. But yeah, getting emotionally attached to a product in a quick turn process is a risky endeavor.
And it's almost unavoidable. I'll put it this way. If you're working on things where you don't have emotional investment, you might be working on the wrong things. How do you as a team come together and look, say, 12 months ahead? Like, how involved are you in that creative process?
It is an all hands on deck situation. And something I love about our process is that I'm never asked, what are you releasing next summer? I'm asked, what is your 5-year plan? And that always forces all of us to think about, what is the company portfolio going to look like in 5 years? What makes sense to release next year versus 4 years from now? So we're always trying to think blue sky, and then also, what can we do today? So I think that thinking as a 5-year plan is very important. We typically are at the forefront of what the landscape market has to offer. So we aren't usually looking to our competitors and saying, oh, they did this year, we better come out with something similar. We're saying, okay, how do we take the existing technology, LED technology, powder coating technology, everything else we use to make an incredible light that people will need? So it's a lot of studying use cases and even design just to see what do people think is beautiful right now and how do we translate that into our lighting designs.
Yeah, I think the trends have to converge, and the leadership too. They have to be willing to support sensible approaches to innovation. I say sensible because, let's face it, there are some fringe lunatics out there who would bring down the whole company.
Well, and that's why it's so important to clarify, what does innovation mean to you? Am I going to sit on a release for a year and make something brand new and perfect? Or do you want to see another 20% brighter product every year?
Do you feel that innovation is part of the design process for the typical electrical engineer, or are there some that maybe shouldn't indulge that privilege?
Oh, goodness. I think if you're not constantly looking for ways to make something better, then again, that might not be the job for you. And that's really all innovation is, right? It doesn't necessarily mean, in the case of lighting, that it's going to be brighter. It might be a cost down in the discrete components, because we have to remember that I think every engineer, even people that are out there making better resistors, we're all trying to make everything a little bit better. We're part of this cycle. And so every time you do a redesign or a new design or anything like that, you've got to be looking for ways to innovate in every single part of the system, right? Is there a new PCB technology you didn't know about the last time you did this? Is there a cap with a better ESR, right? Everyone is trying to make it better, so you're not in it alone. So it's really a shame if you're not constantly trying to make that a part of your design process.
A sincere thank you to our guests, each of whom joined remotely from their home offices to share their experiences around innovation. And we want to hear about yours. What does innovation mean to you, to your company? Where have you succeeded in innovation? And where have your innovations fallen short? Share your stories in this episode's comments on allaboutscircuits.com. And if you enjoyed this show, please drop us a review on Apple Podcasts, Google Podcasts, Spotify, or wherever you subscribe. It's a small gesture that makes a huge difference in helping us to build a strong community of listeners and contributors. We'll see you soon.